Hello and welcome to the Data Engineering Podcast, the show about modern data management. Have you ever woken up to a crisis because a number on a dashboard is broken and no one knows why, or sent out frustrating Slack messages trying to find the right dataset, or tried to understand what a column name means? Our friends at Atlan started out as a data team themselves and faced all this collaboration chaos. They started building Atlan as an internal tool for themselves. Atlan is a collaborative workspace for data-driven teams, like GitHub for engineering or Figma for design teams. By acting as a virtual hub for data assets ranging from tables and dashboards to SQL snippets and code, Atlan enables teams to create a single source of truth for all of their data assets, and collaborate across the modern data stack through deep integrations with tools like Snowflake, Slack, Looker, and more. Go to dataengineeringpodcast.com/Atlan today, that's ATLAN, and sign up for a free trial. If you're a Data Engineering Podcast listener, you get credits worth $3,000 on an annual subscription. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's LINODE, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show.
Your host is Tobias Macey, and today I'm interviewing Shireesh Thota about Singlestore, formerly known as MemSQL, the industry's first modern relational database for multi-cloud, hybrid, and on-premises workloads. So Shireesh, can you start by introducing yourself?
Nice to meet you, Tobias. I am Senior Vice President of Engineering at Singlestore. I have worked at Microsoft for the past 15 years. I've worked in various database engines. I started as an intern at SQL Server when I was doing my master's, and then I came back to do my full-time employment with SQL Server. I was part of various releases of SQL Server, starting from 2005 SP2, which is like a major sub-release, that version, all the way to 2012, built various features for SQL Server. And then I was one of the founding members, like early crew of Azure Cosmos DB. Azure Cosmos DB is a completely different kind of a database from SQL Server. It's a non-relational database. It was primarily focused on being an elastic, geographically distributed database. I did various pieces in Azure Cosmos DB, worked on query engine, inverted index, and then I went on to run the entire engineering for Cosmos DB for several years. I have also, along the way, started running engineering for Postgres Citus, which is an acquisition that Microsoft made. And then recently, I've started working at Singlestore, so I'm here.
And do you remember how you first got started working in data?
As I said, I was an intern at SQL Server, so that happened almost accidentally. I was interviewing with various companies, various divisions, and I had an offer from Visual Studio to work on the debugger as well as SQL Server here at Microsoft, along with a bunch of other offers. But I just picked SQL Server. The problem space and the kind of interactions that I had felt right to me for some reason. And then I enjoyed the internship quite a lot. I worked on comparing large databases and figuring out what is the effective way to figure the delta and moving the schema changes efficiently, etc. I got hooked and came back and joined SQL Server. SQL Server is a fantastic place to get started if you're interested in like database careers. So I sort of got that going, learned quite a lot there. Ever since, it was sort of really, I didn't even work on any other department at Microsoft, even though Microsoft is such a large place. That's kind of really my beginning. And then I ventured into various aspects of data management effectively.
Now, in terms of the Singlestore product, I'm wondering if you can just describe a bit about what it is and maybe what it is about that product that interests you and makes you excited to be working there. And for the kind of detailed pieces, I'll refer people back to the interview I did with Nikita Shumganov a few years ago at this point, which I'll put in the show notes.
Nikita has basically gone through some of the technical details of Singlestore. And in fact, to answer that question, I probably have to refer to some of those pieces because that's precisely why I really got interested in Singlestore. The technology is just amazing. The novel approach of building a transanalytic, tab database, so to speak, is amazing. We basically have a system that can provide you the low latency for operational needs as well as sort of like the large queries, low query latency, and a high concurrency, significantly complex queries of analytical needs in one place. And the way it is done is just amazing, where you take advantage of a row store in memory, and then you tier it into a column store in the disk. And then we've now recently added what we call as bottomless, which is tiering further into an object store. And so we kind of reimagine how you do a log structure storage across these memory tiers, and then done some significant amount of engineering to provide both ends of the spectrum, both on the transaction analytics. So technology is really one of the core reasons why I got attracted to Singlestore. Also, my experience working in databases over the course of several years has taught me that the market and the TAM is just amazing, right? So you really don't go wrong working in a database market. And now when you have an amazingly high potential technology like Singlestore, you sort of have a great combination. And so working with people, talking to them, etc., proves me right.
In terms of the database market, it's gotten to be quite crowded with dozens, if not hundreds of entrants for different special purpose use cases, as well as the sort of old stalwarts of Postgres and MySQL and Microsoft SQL Server and Oracle. And I'm wondering if you can just talk about the different areas of specialization that you see as being part of the broad categories and what you see as the core sets of workloads that Singlestore is aimed at addressing.
Yeah, a little bit of a history would help here. When you think about how this whole industry has evolved, categorized roughly into three different phases, right? In the first phase, where we basically had the simple single node databases, relational, only, and they were basically catering to the needs of mostly operational. Then we were slowly building the models to do OLAP with a very concrete modeling of extract, transform, load into, again, relational based data warehouse, right? Then go to the phase two, where we basically wanted to handle the scale, which the single node databases weren't able to keep up with. And hence the whole NoSQL movement has begun in tandem with the Hadoop and the MapReduce kind of architecture. And that kind of really, it expanded into various other flavors. I would also say the columnar formats have come into vogue in that era, which kind of taught how to do data warehouses in a slightly different way. And then, somewhat of like the data lakes have also begun, Spark computation has come into place, etc. I think we are in the third phase, which is an interesting and most important phase, where we need to do more convergence and not explosion further. What I see here is that the modern data stack, as we call it, is getting more complicated. There is the operational sources, and there are ingestions to do the E and L. And then you have the sources, which are curated sources and query processings. And then you do transformations. And then you have sort of the analytics, dashboards, and whatnot. When you have these kinds of pieces, and they're all very good pieces, they're very good categorizations. But what ended up happening with this categorization is way too specialization. So when you have way too many specializations, then the problem of connecting these boxes and the cost of doing the connections and making sure that the data governance and protection, etc., that goes up significantly. There are great technologies in each of these categories, but the movement of the data and the complexity has gone up quite a bit, which is not necessarily a great thing, even though individually every piece looks great. Singlestore has a view that distinctly, we call it as sort of like the era 3 database, where we want to simplify and converge many of these pieces, right? When you have a database that can unify the operational needs and the analytical needs in one place, you kind of reduce the number of boxes. Significantly large number of advantages come as a corollary. As I said, governance, privacy, those things are definitely far better when you have data in one place. And it becomes a far lower TCO overall, right? Less error prone. So those are the characteristics that we are going after. I would wish the market and the industry embraces that all up. I would consider Singlestore to be far ahead of that.
Because of the fact that it does have a few different types of optimizations that you can take advantage of depending on how you want to execute your workload. I'm wondering if you can speak to some of the unique capabilities that it offers in the market versus the need to incorporate multiple different data stores, as you mentioned, where if you have multiple specialized engines for different use cases, and some of the ways that you're able to leverage the ability for a single store to operate both as a transactional engine and an analytical engine.
When you think about the story of Singlestore, and Nikita has touched upon it in his previous podcast, they started off basically wanting to do a scale out transactional workload, and they bet on the RAMs getting cheaper, etc. And as we evolved, as the hardware trends have evolved, etc., we've added significantly important capabilities without losing the initial view. These capabilities will help workloads which are looking for real-time insights to begin with, right? The kinds of applications that need real-time insights, instant insights on fresh data have only gone up, right? When you think about the financial industry, or even any industry that is facing with data that needs to be fresh to make a call, even rideshare apps in the gig economy, quite a lot of applications require those real-time decisions. Singlestore is, in fact, really a must-have in your toolkit to do those kinds of decisions faster. Because when you have more boxes, more databases, you're effectively losing precious time in moving the data across these boxes, and thereby your time to insight is always going to be low, right? Let alone the cost of moving it and TCO, governance, and all those important problems. The fundamental business value about the real-time insights is something that is an important and a core capability of Singlestore. Now, once you come in there, the other interesting capability of Singlestore is that by the virtue of how the modern data stack has started evolving and creeping, it simplifies it. It simplifies your overall spread of databases. And true to our name, it is a single store. Our vision is to simplify. You don't need a relational single node database, and then you have a document database. You may need an Elasticsearch kind of system. Then you are putting a cache on top of it, and then you're moving that data entirely into a data warehouse. So all these kinds of complexities would be tackled nicely. So that's another core capability of single store, right? So these are the sort of this is how we start, but we can expand and give you so much of benefit with the other capability of simplifying. So I would just touch upon those as our core capabilities. Now, naturally, Singlestore being, it's a general purpose database and it's available in all clouds. You would get the benefit of what you would expect from a cloud native database. Those capabilities are, in fact, very nicely packed into the system.
Given the fact that you have a long history of working on different database technologies from your time at Microsoft, I'm wondering what are some of the lessons that you're able to bring into your work at Singlestore and some of the useful insights that you have gathered from your experiences on SQL Server and Cosmos DB that you're able to apply to the area that Singlestore is focused on and the types of customers and workloads that you're focused on serving?
Microsoft is a magical place, and it's definitely had great lessons working on various kinds of databases. And both SQL Server, Cosmos DB, and Postgres have taught me distinct lessons. But the themes are the following, right? I probably have both patterns and anti-patterns working at Microsoft. On the pattern side, the lessons that really apply here is just like any other database. Singlestore is, of course, just similar to kind of those databases in the sense that it's a marathon, right? When you want to build a database, the results are not going to come in like how you would expect as a sprint, right? The focus needs to be sprint. The execution needs to be like a 400-meter sprint. But building a database is a marathon. It does take a significant amount of effort and time to sort of see the results. And the other thing is to basically understand the workloads, and understanding where you begin and how you optimize those workloads is distinctly a different and a very deep challenge compared to other businesses, right? When you are in a database world, there is this sort of a prime directive here in terms of making sure that the data, which is a fundamental asset of all these companies, need to be protected and never be corrupted, etc. And it's always available. When you're running a service, the scale that the customers expect you to be, it becomes a very distinct challenge, right? Microsoft is a phenomenally great place because it is a hyperscale services, effectively all of them were, and it was dealing with a lot of Fortune 500 customers. And so those lessons are sort of like really deeply inbuilt into me. On the anti-pattern side, when you kind of come from a company like Microsoft into a single store, Microsoft is, of course, a gigantic machine, which does not just databases, but really pretty much everything, every software out there. And so there is a little bit of friction and focus challenges to bring in all the pieces and make the magic happen, right? To approach in the same way wouldn't work in a company like Singlestore, right? And to the product as well, just the strategy, execution, a lot of aspects, right? So those are the places where I tend to be more careful in terms of not applying those approaches.
So looking back at when I did have the interview with Nikita, it's been almost 4 years now, being in October of 2018. And I'm wondering if you can share some of the high-level changes, whether that's changes in focus, architectural updates, changes in capability that have happened in that time from 2018 to where we are today.
Yeah, quite a lot has happened. I will focus on a few most important ones, perhaps. The fundamental piece that has changed is that Singlestore is now a cloud first company. We're not a cloud only company, we're a cloud first company. We've embraced all the major cloud providers. We've basically started exploiting the capabilities of cloud, economies of scale, how well we can horizontally scale the system, how seamlessly can we provide high availabilities, etc. And along with that, it also is probably more appropriate to talk about bottomless. Bottomless is a feature that I alluded to prior, where we tier the data across not just from in-memory and disk, but now we can go to the blob store, the object store. So you could pretty much put really bottomless amount of data, and we scale seamlessly. These kinds of changes were possible because of the shift to the cloud. That's a big business change. That's a big technical change that we've done since 2018, for instance. A ton of optimizations and query improvements have gone into the system. We now have a system where we have a compelling benchmarks on TPC-H, TPC-DS, as well as on TPCC. By the way, that's kind of really very novel for a system to be good at all these benchmarks in one place. And that's possible because of so much more work that has happened in the query storage areas, right? So those are some of the top changes that have happened since then.
Data teams are increasingly under pressure to deliver. According to a recent survey by Ascend.io, 95% reported being at or over capacity. With 72% of data experts reporting demands on their team going up faster than they can hire, it's no surprise they are increasingly turning to automation. In fact, while only 3.5% report having current investments in automation, 85% of data teams plan on investing in automation in the next 12 months. That's where our friends at Ascend.io come in. The Ascend Data Automation Cloud provides a unified platform for data ingestion, transformation, orchestration, and observability. Ascend users love its declarative pipelines, powerful SDK, elegant UI, and extensible plugin architecture, as well as its support for Python, SQL, Scala, and Java. Ascend automates workloads on Snowflake, Databricks, BigQuery, and open source Spark, and can be deployed in AWS, Azure, or GCP. Go to dataengineeringpodcast.com/ascend and sign up for a free trial. If you're a Data Engineering Podcast listener, you get credits worth $5,000 when you become a customer.
You mentioned that it has moved into the cloud. That's obviously a huge area of growth for most companies. I'm wondering what are some of the other macroscopic trends in data management and application development and just the overall surrounding technical ecosystem that have pushed it in that direction, and just some of the ways that those trends have impacted the product direction and areas of focus.
Definitely, the scale aspect is one of the macroscopic trends that pushed us into the cloud, right? When you're talking about elasticity, it's really hard to do it outside of cloud. We want to be seamlessly elastic. We want to go from no amount of data to a significant amount of data, no amount of throughput to a high amount of throughput, and really, pay as you go effectively, consumption-oriented fashion. Those are some of the important metrics, right? The high availability aspect is another very important aspect of modern-day mission-critical kind of applications that pushed us into the cloud. But in addition to those, the application trends, if you look at how significantly broad number of applications are being built on databases, application developers, by and large, want an integrated stack. The best and most popular one that people know of is Mean Stack, for instance, right? And there are a bunch of others as well. There used to be LAMP, now it's Mean, and there are many other stacks that are popping up. But they want integration of databases and frameworks all the way to exposing something that is sort of so seamless that you provide the backend as a service, right? Where the applications are just working on single page mobile applications, single page applications. It's smooth, seamless, without having to understand the sort of like the depths of the relational algebra effectively, right? The other trend is consumption orientedness, right? When you want to build applications, you want to go from very little amount of money to potentially a mission critical application. You want to make it easy. And so the serverless paradigm is another one that is changing, and Singlestore is definitely evolving along with it effectively.
And you mentioned recently the idea of the modern data stack. That's something that's gaining a lot of mind share and airtime right now. I'm wondering if you can talk to for engineering teams that are already invested in or starting to think about adopting that architectural pattern and that paradigm. Where does Singlestore fit in that overall architecture?
When you think about the modern data stack, again, this is a definition, but roughly the definition is that you have operational sources and you have, ELT with the storage and query in between, and then you have the dashboards and the insights on the far end, right? Singlestore can simplify many of these pieces. To start with, it's an operational store. We have begun the roots of the company, and basically it's a row store, transactional, but scalable system in memory. So, and then we've expanded it further, of course, but we can be seen as the operational source of truth. We can be used as the intermediate phase where you basically extracted the data from various sources, ingested into a storage and a query format for the analytical needs, especially on the real-time analytics as well as broader analytics. We have many customers who do that. So we can play on the operations, on the analytics piece. We do the ingestion very seamlessly. If you use Singlestore as the operational transaction and the analytics, you don't even need the intermediate pipes anyway. But if you're coming in from a different source, we support seamless ingestion with very native feature called as pipelines that work with Kafka and a bunch of other streaming data. So we can do that very nicely. Those are the real-time insights, of course, really, really good at it. We have great integration, amazing partner ecosystem, but effectively think of it as operations as well as the intermediate storage and query for analytics. Those are the areas where we can do a very good job effectively.
In terms of the simplifications that an engineering team might expect when they're adopting Singlestore, where maybe they have gotten used to this idea of, I've got my operational store and now I need to do the extract and load into my analytical store, just some of the operational and application and system architecture considerations that they need to be thinking about as they move to Singlestore, and some of the types of capabilities or efficiencies that they might expect by moving in that direction?
Yeah, so fundamentally, Singlestore is a relational engine, right? It's relational foundational, but it is also a multi-model system. We have various kinds of type supports. We can do spatial, JSON, time series, and whatnot. But we are a relational system, and we take care of the art of converting an operational friendly data modeling to an analytical friendly data format. We took that. It's completely transparent in the sense that you just ingest the data as though you're ingesting into an operational store. And internally, we take care of transforming the data into columnar format in the right way, and then supporting various data models. So that translates into a significant amount of developer benefits, because the developer doesn't need to go and do all the modeling exercises, need not do the data engineering pipelines to move the data across, doesn't have to figure out, hey, which part of the data needs to become columnarized, which parts shouldn't have to, how do I do the tiering, how do I do the sort of translation of various pieces, etc. And you don't have to work with complex pieces to then go into a real-time insights kind of a platform. They're all in one place, which means a significant saving in dev time, let alone the benefits in the production.
And from the analytical perspective, if I recall, it also has some built-in capabilities for being able to do some of the extract and load as part of the engine runtime, so you don't necessarily have to bring in another tool like a Fivetran or an Airbyte to be able to feed data into it, that it can actually go and do some of that retrieval of data into the storage for analytical purposes.
That's true. It depends really on the volume and the requirements. We work with those tools very well. If you have a DBT, for instance, we work with that connector, and if you're bringing in data, etc. But fundamentally, we have key capabilities in the system. Again, I refer to it as pipelines, which will help you move the data seamlessly. If you have a change data capture from an operational source, you can put in a Debezium kind of an approach there, and it works very well with our pipelines. And then we have very rich store procedure support. We are also adding, in fact, this is a new thing that's coming out, WASM support, to be able to take in WebAssembly runtimes natively in the engine to do the transformations locally, right? You don't have to move the data out, right? So there's quite a lot of that support inbuilt inside the system. While we work with the ecosystem, a lot of your needs probably don't even need them, because we can do quite a lot of that transformations locally. And again, with pipelines, the extraction and the loading part gets significantly seamless.
And so for people who are used to the idea of I have my operational store and I've got my analytical store and I'm going to move data between them, there's usually some other aspect of mutation of the data model to be able to make it more conducive to that analytical workload. But because of the fact that you're able to have your operational and your analytical workloads coexist in Singlestore, possibly on the same sets of data, I'm wondering if you can talk to some of the ways that that influences how teams think about data modeling for their applications so that it is also useful for analytical purposes beyond just the built-in capabilities of treating it as a row store in memory and a column store on disk.
So Singlestore effectively has one model where it's relational foundational, and basically you'd have to go in and ingest the data in one model. There's no operational model and analytical model. It's really just one thing. So if you think that your requirements are better suited with, let's say, a Snowflake schema or something like that, you would go ahead and do that. But our query engines are pretty capable enough to provide you the operational goals that you might have, that you basically suck the data in whatever schema that you have, and then provide the right optimization based on whatever model you have. It works really well, fairly well for the operational goals as well. You may need to do some adjustments based on your goals for your application. You probably are a lot more on the analytical heavy and a little less on the operation side, so you make those adjustments based on that. And naturally, Singlestore has some of the capabilities like materialized views, etc. And we're working on some of the gaps there, but those will also help to evolve subtle translations between the data models your application might need.
And because of the fact that it is available as a cloud service, I'm wondering what you see as the ways that teams consume the product, where maybe they have one instance deployed for their different application use cases and another one deployed for their analytical use cases, or is it more a matter of they have one widely scaled instance with different schema definitions for their different applications, and then they just use those view capabilities or some translations into analytical tables within that same schema space for powering their business intelligence dashboards and things like that?
It's definitely a mix. We have customers who use it as like a, purely like one place for all the tables with various schemas and various needs. And there are some customers who would have those logical partitions, right? Depending on really the kind of customer and depending on the type of the workload, when you think about the enterprise sensitive workloads, they might do some logical partitioning. But there are lots of SaaS companies who would basically do mixing up all of the data is in one place, and you could run all kinds of workloads in one place, both heavy operations as well as your dashboards all in one place, right? And that's the beauty of Singlestore. You don't need to really change your developer experience, your IT skills to switch between these needs.
So now your modern data stack is set up. How is everyone going to find the data they need and understand it? SelectStar is a data discovery platform that automatically analyzes and documents your data. For every table in SelectStar, you can find out where the data originated, which dashboards are built on top of it, who's using it in the company and how they're using it, all the way down to the SQL queries. Best of all, it's simple to set up and easy for both engineering and operations teams to use. With SelectStar's data catalog, a single source of truth for your data is built in minutes, even across thousands of datasets. Try it out for free and double the length of your free trial at dataengineeringpodcast.com/selectstar. You'll also get a swag package when you continue on a paid plan.
And so we've discussed a number of the different capabilities of the engine, of being able to operate as a row and a column store, transactional and analytical use cases. It has some abilities for being able to do data ingestions and building these pipelines. But what are some of the other features and capabilities that are either underappreciated or overlooked by people who are new to the system that you think are worth calling attention to, explaining some of the ways that teams who are used to maybe a Postgres or a MySQL can think about and take advantage of those additional kind of value add features?
One of the key things that I would like to focus the customer's attention on this one is the fact that this is really the only system that has fantastic TPC-H, TPC-DS kind of workloads, and also a very respectable TPCC workload benchmarks, right? And that is incredibly novel. Now, of course, that goes back to the fact that we are both operational and the analytical database. But it's not just any vanilla HTAP database. It is so good that it can compete with the industry-grade relational databases, the single-node relational databases like Postgres, MySQL on one hand, and sort of like the industry-grade data warehouses like Snowflakes, BigQueries, etc. In fact, we beat many of them on these benchmarks. That's a fact that sort of surprises a lot of our customers when we talk about it, but that is one of the overlooked aspects of Singlestore. It's not just a sort of like a simple HTAP database. It's a lot more powerful. And there are a ton of other features. When you think about these kinds of capabilities, some of the customers may have the impression that they don't scale, right? There's a contained specific amount of storage, etc. Not at all. It's very distributed. We have done tons of improvements, not just on the storage and compute, but also on the query processor, right? We've invested significantly on our optimizer, execution layer altogether to take advantage of the economies of scale in the cloud, and then bring these HTAP capabilities to life in a distributed scale. Those are the few features that are a little bit surprising for some folks to hear, but they're 100% true.
In terms of the applications of the technology and your experience working with some of your customers and managing your team, what are some of the most interesting or innovative or unexpected ways that you've seen it applied?
Even the spread of our capabilities, the spectrum of capabilities that we offer, sometimes customers use it for very interesting workloads, right? We see this happen. Of course, the sort of the common ones are financials and the entertainment, the gig economy applications, etc. Those are sort of most common ones. But time and again, we see some of the interesting ones, like there was a face recognition app that was built. The data was all bitmap, and yet it sort of figured out our key capabilities were very relevant to them in terms of how we do our vectorized query execution and compressed data. It worked out really well for them. So those kinds of applications do pop up once in a while.
In your own experience of working at Singlestore, what are some of the most interesting or unexpected or challenging lessons that you've learned?
I think the interesting piece is really the engineering trade-offs. When you think about achieving these significantly hard goals of trying to become a single store of transaction and analytics, you got to make the right engineering trade-offs. Every trade-off has an interesting history, and how we've evolved it and how we've sort of executed it has always been interesting. It always surprises me whenever I learn more details about it. It is not magic, but it is quite a lot of hard work in terms of getting it done and perfected. We are just quite ahead on that curve, and that's kind of super interesting. For me personally, with the Microsoft pedigree, there are challenges in terms of big company, small company, different kinds of customer base versus the new era of customer base. So there are differences across the board in terms of Microsoft customers and Singlestore, for instance, right? There have been a lot of challenges and surprises, pleasant ones in that regard.
And as far as those customer conversations, because of the fact that Singlestore is fairly unique in the marketplace as far as the set of capabilities that it provides, I'm curious what you have come across as some of the points of customer education that you've had to keep coming back to, or the typical sticking points that you run into as people are starting to maybe, fight against the idea that Singlestore is the right answer for their problem.
I think customers have, let's say in some cases, they have already set into a certain kind of an architecture. They have a tooling to do the ETL. They already have a tooling to cleanse the data in a certain way, curate it and put it into a warehouse. And then they already have certain licenses for query engines, etc. And then when you come along and try to disrupt that, there's a bit of a friction in terms of how do you move all that is already there and then, sort of bring in here. And there's some amount of adoption challenge in terms of how do we move from all these pieces into one piece, right? So when we talk about the value, we bring in incrementally and try to sort of like help you take the entire stack and simplify it. Those kinds of conversations they end up with what's the catch, right? What is exactly that we are giving up? We basically have a conversation which is rooted in the fact that it is as simple as really doing the engineering trade-offs, and you're not really losing much, right? And that explanation takes a little bit of time, right? It is sort of like a sticky point that comes over and again.
Given the fact that databases can be so sticky because of the fact that that's where all of your data lives, and doing a migration can be very difficult and potentially risk or error prone, I'm wondering what are some of the ways that Singlestore is able to simplify that process of saying, okay, you're coming from database X, it's going to be very easy. We'll, just consume the write-ahead logs or the bin logs to be able to replicate into our engine, and then you just cut over once everything is synced up and you're happy with it. I'm just wondering what you see as some of the ways that you're able to kind of ease some of those concerns and simplify that migration process for people who have existing workloads and they just want to be able to add in the new capabilities that Singlestore provides.
Yeah, we're very committed to helping customers be sort of not feel like they're locked into a vendor. To start with, we are completely cloud neutral. You could basically go into any of the clouds, and you could, in fact, have the data spread across one cloud to the other, etc. So really don't want you to be locked in anything. We've embraced MySQL via Compat, which is obviously a very open source, sort of like it has its flavor, but it makes it easy in terms of how you move the data out of our system, into our system, etc. Your applications and drivers are compatible largely. So what happens inside the system is significantly different than how, let's say, MySQL does it or Postgres does it. But we sort of have the interfaces and APIs to import, export in an agnostic fashion, very open source friendly fashion effectively. And we're working on lots of features in terms of sort of enabling the data sharing and accessing the data easily, and we'll have more to speak about it over the course of next few months. We'll make it easy for customers to really just ingest and export effectively.
For people who are looking at a choice of which database engine and which database technology to use, what are the cases where Singlestore is the wrong choice?
I think really the only case where if you have a simple application, you're very comfortable with a relational database that's single node, like you don't need to scale, etc. You just have vanilla ANSI SQL kind of needs. You don't even have multi-model kind of needs, no modern application needs, etc. Then you might be happier with what you have, like a vanilla Postgres or MySQL might do. But most of the applications, these are evolving. Even those single node, simple applications do want insights, etc. So things are changing quite a bit there. But that's kind of the starting point where it might not be needed, right? But as I said, the value addition is much more than just scaling or sort of trans analytics. It's more than that. So things are changing fast.
As you continue to iterate on the product and try to grow adoption, what are some of the things you have planned for the near to medium term or areas of focus that you're excited to dig into?
We are announcing a couple of features pretty soon. I talked about Wasm, which is basically, running the WebAssembly runtime natively inside the engine. We are doing workspaces, which are basically compute and compute isolation, meaning you can bring in different kinds of computes on the same data. You could do, on demand, you could attach more compute and throw it away if you don't need it. You share the data seamlessly that way effectively. We basically are committed to building seamless elasticity, consumption-oriented seamless elasticity effectively. We're committed to building a significantly high availability, sort of like disaster recovery across regions, multi-zones, etc. We committed to building a compelling developer experience, right? And making sure that we push the boundaries on the cloud first. The fiber of the company is to make sure that we push the vision of a single store, which is really having both transactional and analytical in one place. So we'll do more and more work on evolving our query engines, query optimizations in terms of beating these, being really fast, because it's sort of the core tenet of the company. So those are always there. Those are foundations for us. But real-time analytics, high availability, seamless elasticity, compelling developer experience are some of the common themes that you would hear in our engineering hallways.
Are there any other aspects of the Singlestore product or the capabilities that it provides or the ways that it's being applied that we didn't discuss yet that you'd like to cover before we close out the show?
I think, again, as I talked about, Wasm and workspaces, for instance, are coming, and we've done significant amount of work in terms of building a compelling query experience, very performant query experience across multiple nodes, right? These are some capabilities that are really not available in the market to the scale and to the perf that Singlestore offers. Those are a few things that I'd call out in the near term. And then as we go along and as we start building, I'd love to come back and talk about them in the near future.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
So I'll start with the gap and then I'll talk a little bit about the challenges in the other direction. We're so focused on the modern data stack across all these various boxes in terms of the sources and the analytical dashboard and the whole ELT, ETL in between, that I think there's a lesser focus on the governance and the security aspects. I'm not saying it's completely lacking, but we need to do more on the governance of the data and security, which is becoming a significantly important topic. And it gets more complicated with sort of like expansion of these phases, right? And that's an area where we need to be a lot more careful in terms of really questioning every aspect of those phases, and every box and an arrow that you draw. You need to be conscious of the fact that, well, your data is now exiting from one premise to the other, so you need to do more surface area threat modeling and all those pieces, and governance, lineage of data gathering, etc., becomes harder. So those are the areas that are sort of negative corollaries of the evolution of the modern data stacks. I think that's an area where I wish we focus more and kind of place into the vision of Singlestore, which is to simplify. So you get to do your governance and security and those pieces in one place and do it with simpler tools and more efficiently.
Well, thank you very much for taking the time today to join me and share the work that you've been doing at Singlestore. It's definitely a very interesting project, an interesting engine. Definitely great that it is available on the market to help simplify the operational and analytical architectures for engineering teams. So I appreciate all of the time and energy that you're putting into helping drive that product forward. And I hope you enjoy the rest of your day.
Thank you, Tobias.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.